Probability with Venn diagrams. In this slide, we have 3 different examples that show events, and I'm going to go through some of the vocab and some shading, and the shading will indicate what the probability is that we're trying to find. So in the first one on the left-hand side, you see the word union, which is also corresponding with the word or. Now we've talked about that in the past where we say it's one event or the other event and how to find the probability of one event or the other event. Now imagine that the events are A and B. If we're trying to find or, that means that it could be A or it could be B. So we're talking about both events together. How we write that is we use this symbol A, and then it's this upside down U, and that means or union, B. So A or B. In the middle diagram, we're looking at the intersection. So the intersection of event A and B. So the only part that is intersecting is where the actual circles intersect. How we write that is we have the event A, and then we have that same symbol, but it's upside down, and then we write the event B. So this means A and B. So it's where the two events are overlapping. So both event A and event B are occurring. On the right-hand side, you see the word complement. The complement means everything except for the event. So let's say we're saying that we're going to find the complement of event A. The notation for that is A prime, so it has a little hash mark. So that means everything except A. So that means I'm going to shade outside of this A circle. So the highlighted part is the complement of A, meaning not A, or everything except for A. In example 1, we're going to do some shading just to get the hang of the Venn diagrams. So for A, it's asking us to shade event A. So I'll take my yellow highlighter and I'll just fill in the circle of event A. Notice that event A does share some space with B and C. For B, it's asking us to do the complement of B, so everything except for B. So I'm going to just kind of outline B here. Very sloppy, sorry. And then I'm going to shade everything outside of B. For C, we're asked to do B and C, so the intersection of B and C. So I've outlined it, and then I'm going to shade in that intersection. So I'm really just focusing on the B circle and the C circle. For D, it's A union C, meaning A or C. So I'm going to highlight A, all of A, and I'm also going to highlight all of C. For E, it's asking for A and B and C. So it's asking for where all 3 events are overlapping. That's just in this little middle section. And then for F, it's asking for A or B and C. So if I start with A or B, I'm going to highlight the A and the B circles. Then it's asking for and C. So out of those 2 highlighted portions, which part is also part of C? So my final answer is actually just the portion that has the blue lines. Now that we know how to read a Venn diagram, let's actually put some numbers in our Venn diagram and answer some questions. So if the Venn diagram alongside illustrates the number of people in a sporting club who play tennis, T, and hockey, H, determine the number of people, A, in the club. So let's go back to the first sentence. The Venn diagram illustrates the number of people in the sporting club. So let's look at all of the numbers. We have 15, 27, 26, and we also have this 7 that's hanging out here. They're still members in the sporting club, but perhaps they don't play tennis or hockey, and they could play some other sport. So they are counted as being in the club. So when I answer question A, I'm going to add 15 plus 27 plus 26 plus 7 for a total of 75. B asks for the number of people who play hockey. So I'm going to look at the right-hand circle, and we have 26 people who only play hockey, but we also have 27 people who play both hockey and tennis. Can include people who play both. So 27 plus 26 is equal to 53. We weren't asked for people who play hockey and not play tennis. So that's why we can include that 27. In C, we're asked for people who play both. So that's just going to be that overlapping, which is 27. In D, we're asked who play neither sport. That's going to be our 7. And in E, we're asked who play at least one sport, meaning that they could play one sport, but they could also play two sports. So we have the tennis and the hockey, and then we also have both sports together. So we're going to add 15 plus 27 plus 26, which is equal to 68. In example 3, we have another Venn diagram. So the numbers that are placed in the events are raw numbers. Depending on what the events symbolize, they could be people or objects, whatever's outlined in the question. So Mr. Dugan wanted to find out the students' opinion on Star Wars versus Star Trek. He went out and polled 190 Skyline students, and these are the results. So the results are on the right-hand side with our Venn diagram. This means that 40 people only liked Star Trek, 70 students only liked Star Wars, and that 20 liked both. Then we have a remaining 60 students, because we have a total of 190 students that were polled. And they are in the outside of the event circles, but yet inside the rectangle of being part of the opinion poll. How many students enjoyed the Star Wars? So the number of students that enjoyed Star Wars are the students who only liked the Star Wars, but also the students who enjoyed both. So we're going to add 70 plus 20, which is 90. How many students enjoyed Star Trek? That would be the 40 and the 20. We add those together, and we get 60. How many students don't like either? The students that don't like either are the 60 in that bottom right-hand corner. So they're not included in either event. In example 4, we're moving from raw scores into probabilities. So the first thing I want to remind you about is that probability is a number between 0 and 1 and including 0 and 1. So when we're given this Venn diagram that lists probability, we have to make sure that all of the data listed adds up to 1. So whether it's inside of the events or just inside of the entire poll. So when we're asked to find x, we need to take all probabilities, so 0.2 from inside event A, plus 0.35, which is shared of A and B, plus X, which is event B, plus 0.2, which is the complement of A and B. Those all have to add to equal 1. So we can solve for X by setting up this equation. When we simplify and solve for X, we get 0.25. Now let's go and answer the questions before. Find the probability of event A. So the probability of event A is 0.2 plus 0.35, which is 0.55. The probability of event A or B, remember we have that union there, will be 0.2 plus 0.35 plus 0.25. which is 0.8. Find the probability of the complement to B. So that little c there is the same as B prime. So the complement. So anything outside of B. So that would be this 0.2 and this 0.2 added together, which adds to be 0.4. And the last one says the complement of A or B. Well, we already found A or B to be 0.8. So we can actually take that and subtract it from a total of 1 to get 0.2. If you don't want to do it mathematically like that and you want to look at the actual Venn diagram, the complement to A or B, if I highlight A or B in yellow, the complement would be what's left over, what I just circled in green, so that's 0.2. The one thing to remember, that the probability of an event plus the probability of that event not happening, which is the complement, is equal to 1. In example 5, we're going to take the list of probabilities that we were given and we're going to apply them to the Venn diagram. So we have 3 different events that are overlapping. One of the tricks for doing these questions is starting from the inside and going out. So it's nice that they gave us the intersection of the 3 events first, so we can put that right in the middle of where the 3 circles overlap. In the next piece, we're told that the overlapping or the intersection between A and B is 0.25. So I'm just going to start by highlighting this. To give you a visual, the overlapping between A and B is this highlighted part in blue. So if we know that the entire highlighted part in blue is 0.25, if I put an X in the part that's missing, well, that means that I know that X plus 0.11 is equal to 0.25. So I can rearrange this to solve for X. So X is going to be equal to 0.14. So I'm going to replace that in my Venn diagram. Now let's move on to the next one. The intersection between A and C is 0.16. So if I highlight the intersection between A and C, and I move that X, I'm going to put X down below. So X plus 0.11 is equal to 0.16. And that 0.16 we're getting in the question. So I rearrange and I solve, and I get 0.05, and then I can put that in my diagram. The intersection between B and C is 0.17. So if I now change the position of my X again, X plus 0.11 is equal to 0.17. To get x by itself, it's 0.06. Now let's move on to the events for all of A, all of B, and all of C. We'll start with the probability of B. So the entire event B has a probability of 0.4. So if I put that x in the remaining portion, that means that x plus 0.14 plus 0.11 plus 0.06 has to add to 0.40. So I subtract the terms on the left-hand side from both sides, and I simplify to get 0.09. I move on to the probability of A. So the entire shaded region has to add to 0.46. I'll place my x in there. X plus 0.14, 0.11, 0.05 equals 0.46. I subtract the numbers from the left-hand side over to the right-hand side, so x is equal to 0.16. And we're almost done. Lastly, the probability of event C, this entire circle. If I put x in the remaining part of C, x plus 0.06 plus 0.11 plus 0.05 is equal to 0.39. So x simplifies to be 0.17. And now I've assigned all of the probabilities. We aren't quite done yet though, because remember, all probabilities have to add to 1. So the question is, if we add up all of these numbers together, do they add to 1? And for the sake of time, I will tell you that they do not add to 1. They add to 0.78. So that means that we need a number that's remaining to go inside of our rectangle. So basically, the probability that it is not event A, B, or C. So to find the complement, we will take that 0.78 and we will subtract it from 1. So what's left over is 0.22.